Welcome to the special MPA Drainage Roundtable hosted by MPA Precast at Marshall's Design Centre here in the proud city of Birmingham. In fact, the city is highly appropriate for a discussion about the UK's water and drainage infrastructure and the position of precast within it, as well, given the city's extensive network and canals and waterways, which on occasion maybe outshine those of the better known Venice. But without delay, let me introduce you to our esteemed guest. First, Joe Bradley, Director of Operation at Stormwater Shepherds, a not-for-profit organisation seeking to instigate changes in behaviour to reduce stormwater pollution. Professor Baker Chiera, Professor of Environmental Pollution at the School of Civil Engineering and Surveying at the University of Portsmouth. She's an expert in pollution, and the primary purpose of her research is to define the sources and the fates of pollutants in the environment and develop interventions to prevent or mitigate their impact. Professor Nicole Meacher is the director of the UKCRIC, or UCRIC, I hope that's nothing, National Buried Infrastructure Facility, and co-director of the Institute of Quantum Technology at Birmingham. She's an international leader in the development of applications of sensors for buried infrastructure and assessment and monitoring. Next, we have Pete Tamblin, Head of Design and Engineering at Marshall's Civil and Drainage. He's instrumental in bringing together the knowledge and expertise of the Marshall's team in order to design, manufacture and deliver sustainable infrastructure, water management and retaining wall solutions for a safer, better built environment. To my left, Dr. John Gumble, the owner and director of JG Pipeline Consultancy Limited. He has developed the Gumble Distribution for Pipeline Development, a landmark approach for how to lay pipes. His work was instrumental in designing the standards for laying buried infrastructure. I'm sure he's going to talk a bit more about that later. And then, obviously, we've got Steve from the MPA, Steve Callow, I should say, as well. He needs little introduction, championing concrete, particularly masonry and precast, as a go-to material for day in, day out, and I'm sure we'll be delivering more of the same here. So let's get into the discussion. So let's set the scene. Water, drainage and wastewater management are an emotive topic in the UK. Ageing infrastructure, perceived lack of investment has driven column inch after column inch in the media as well, and certainly drawn a lot of public ire as well. Is it fair, and what can be done? But let's look at some of the challenges we face first. There's no doubt many exist within our water and drainage infrastructure, and it'd be great to tackle a few of these head on as a starter for 10. Now, Joe, I know you and I had a bit of a discussion previous to this roundtable about that, and you've got your views on that. What are your views on the current resilience, or say lack of resilience, within our water and drainage infrastructure?
Oh, crikey. Well, I'm quite an interesting person to ask that question of, because I don't particularly think that the sewerage industry is as bad as everybody says it is. So I think there's a lot of bias in the press, and a lot of the blame is laid at the doors of the water industry, and actually the pollution I deal with day to day comes from urban drainage and lack of investment in urban drainage infrastructure, and particularly highway drainage infrastructure. And in fact, I had a long conversation on LinkedIn yesterday about investment in pollution control in agriculture. So I think it's too easy to say that the problems we face today are a result of lack of investment. I'm not sure that's strictly true. I think it's that the investment has been made in the wrong way. It's not been proportionate. So it's not been the investment hasn't been made proportionate to the sources of pollution, and that's the problem. So we've invested in some places and not in others, and we've left rivers polluted. For the last 20 years, they haven't really improved as quickly as they were previous to that, and so there's a lack of investment. And I mean, we're surrounded today in this lovely venue with images of sustainable drainage systems, and that's where we need to shift the focus a little bit more towards sustainable drainage systems and a more proportionate application of investment across all sources of pollution rather than just sewage.
Fair, is it something you concur with?
Absolutely. I think anything that is a point source, and so we tend to look at the water companies and sewage, the outflows from sewage, as a point source. So we think that's the best place to treat, but there are huge areas of either diffuse pollution, and agriculture is a large contributor too. So I do think we need to do more within the wastewater industry in terms of cleaning up the water quality that is going out into the rivers. But that also comes at the moment with the compromise that the sludge, which we then put on agricultural land, often contains the things we've taken out of the water. So understanding that compromise and understanding how to remove the contaminants entirely before we put them out into the environment, whether that be to the water or to land, I think that's where my work really focuses.
And something I was going to ask, and again, this is a sort of general question, is there a bit of too much of a one-size-fits-all approach to the way that we currently approach, say, water infrastructure, sewage treatment management, so on and so forth, as well? And does there need to be maybe a bit of fresh thinking within the industry, within the policy process, so on and so forth, as well? I don't know who would like to take that question.
I think the policy definitely needs a shake-up, but if you look across the work that the water companies are doing right now in AMP8, which started 3 weeks ago, something like that, the range of solutions that are being delivered is fantastic. The different water companies are doing different things in different places and lots of different new things. So I think that's great, and we should encourage that.
If I may add, I think the policy is really key here, because at the moment the understanding is let's focus on infrastructure that we understand and we know how to control. So I would rather have an asset that I can control for a certain number of years and understand the life cycle for. When you start talking about SUDs and some of the green infrastructure, where does that fall? Is that council? Is that water company? And that really needs to be made very, very clear so that everybody can move forward with these great ideas that they're coming up with.
I think also with the AMP8 process at the moment, it's all short-term problem fixing rather than necessarily planning for that overall long-term, where's this going to look in 10, 20, 30, 100 years' time? Yes, we're designing for climate change, but that doesn't mean we're designing systems for climate change. We're just designing systems for the amount of water, but not actually the wider picture of pollution.
A number of years ago, there was a real crux kind of point where you had, very much along those lines, one site would be designing for a 1 in 30 and then a 1 in 100. It would be isolated in and of itself. You'd have a developer that was doing that, working with the water authority, who then wasn't talking to the local council, who then wasn't talking to the highways agency. You had 3 major contributors to how that water was then processed downstream, none of which were interlinked in any way, shape or form. You had 3 isolated little pockets, all of which doing the right thing, but no interconnectivity between the 3 design standards. Those three major bodies that control a lot of discharge, not working together.
I also agree that short-term thinking is really sometimes hindering how we do things. So having these AMP periods, so from a research viewpoint, we would like to install sensors, we would like to install, to do things differently, but also thinking about the life cycle, because we know that our existing pipes they don't have a design life of 160 years, but that's what the renewal period currently is, 160, 180 years. And I think what I see is that we seem to do things the way we've always done it, with some tweaking, some slight changes, but really trying to think what legacy do we leave for the next 100 years or so, because we are creating, we've got problems now that we are trying to overcome because of our Victorian assets, of our assets that we've put in 50, 60, 70 years ago. But we still do things very similar, and we are just perpetuating that problem, and we're just pushing it forwards into the future. So if we are trying to think of doing something slightly differently now, that would actually help us. But while we look at AMP periods, that's always a problem, because the return on investment might be in 20 years, in 30 years, in 50 years. But water companies and probably the government is not really prepared to take that long view of the situation.
Well, they're targeted to limit discharge. And that's it. And if they don't limit discharge, they are fined, which then has a detrimental effect on the whole projects. So.
Is there a similar situation of almost a dog chasing its tail in this as well? And it sounds a bit like that, in the same way that you might think about any funds for new housing going basically back into recladding buildings. Is there a case of that there's so many problems with the existing infrastructure, it's harder to invest in that innovation, which will help address some of the sort of bigger issues down the line. And some ones I was thinking of was maybe around microplastics as well, and how they are either filtered out or removed from the system as well. I don't know, Faye, if that's what you...
Yeah, the research world has come on hugely in the last couple of decades in terms of what we can analyse. And the more we can analyse, the more we do analyse for, and the more we become concerned. Okay, so it wasn't just microplastic, it wasn't just a PFAS, it wasn't just, there's all of these things that we're starting to see, and that's not specifically an industry problem, that's a societal problem as well. Many of these things are pharmaceuticals that we ourselves are taking and then putting into the water as they go through the sewage. So we are the same, exactly as you mentioned before. It's all very individual. We could look at microplastics as an individual emerging contaminant. We could look at PFAS as an individual emerging contaminant, and we can talk about their impacts as individual things. But actually what we need is that much broader and longer term view where you think, okay, there's multiple issues here. How do we solve all of them, or as many as we can, within the system, as opposed to saying, right, I'm going to put this in here for that one thing, and I'm going to put this in here for that one thing. Because there are other ways, other methods of looking for solutions, which would maybe not give you 100% removal, but would give you 80% removal for multiple contaminants. Yeah. And there's no joined up thinking about that sort of thing yet. And I think that's the same both on the contaminant side and on the water emission side.
And then the other thing I was going to ask in and around the streams, because obviously Joe, you and I had that good chat a couple of weeks ago, and one thing that you said that we're all screwed if it doesn't rain before Easter, and unfortunately it didn't rain, I don't think, before Easter. And so what are the consequences of that on the actual water infrastructure now with these? What we're going to have these longer periods of dry spells, so on and so forth.
So I'm not an engineer, so I can't talk about the effects of shrinkage and all those things that go on when it dries out. But certainly we are in Lancashire. It genuinely hasn't rained now for about 14 weeks, not properly. And I was out at the weekend walking the dog, and the little stream that the dog normally walks in, there was no water in it. And that it's shocking to reach the end of what is theoretically the recharge period for water resources and have no water in some of our streams. But there'll be a knee-jerk reaction to that. There'll be a drought declared, theoretically or potentially in the summer. We'll manage water use for that short period of time, and then it'll rain and we'll all be fine and we'll all forget about it. That's a massive problem. We've got to get far, far better at, like you say, doing that, looking at the whole system in the long term and thinking, okay, it's not going to rain in the same pattern as it always did. So how do we invest in infrastructure that recognises that and retains water, uses less water, shares water, recycles water, soaks water into the ground in sustainable drainage systems so that we keep our soils healthy? There's a massive need to shift to there. But if you listen to what Faye's just said about this need to shift to widespread pollution control, looking at all pollutants, and then we're also looking at water management for drought and water resources, and then we're looking at infrastructure needs and monitoring. There's so much to do. I have no idea how we do it all.
Well, we got, in the drainage industry very specifically, we were very early hit with understanding some of the effects of climate change, because I'm sure Pete saw this as well, but very early on when some of the understandings about how water flow would become boom and bust, sort of, these super high peaks of designing for massive tanks of huge infrastructure below ground. We don't see it, it's all buried, people don't sometimes even realise it's there. And then that massive facility has to then deal with incredibly low flows. Well, how do you stop that silting? How do you stop sediments and everything blocking that whole system up? I mean, dry weather flow channels came back in with a vengeance in the early 2010s and things like that, when we suddenly understood you had to design for 1 in 100, you had to design these massive tanks, and all of a sudden nothing would be going through it. During these quiet periods, you had to stop it from backing the whole systems
or
up.
popping out of the ground.
Every problem that you can imagine, when it was, high water tables suddenly were changing, low flows were becoming an issue because we didn't have enough hydraulic sort of in the system to drive all the silts out. Became a huge headache. All in a funny way, it drove us back to some old systems such as dry weather flow channels that drove us back to doing that, to keep flows up, to manage that low water level, and the low flows, which just, it became a huge part of how we designed those big systems below ground. Massive part of it.
And maybe then is a good point to ask also, given the amount of research done, where does Steve precast sit within this discussion and conversation as well in terms of, its suitability to help deliver change?
The interesting part of it is there's always been lots of solutions in it, and as Joe said, there's a lot of SUDs now involved in city centres. I think one of the most interesting things I found was when I read one of the papers, Faded, we saw a lot of these pollutions in the waterways around cities and areas of the coastal where you have these big build-ups. Water is, very clearly running through urban centres and then going into our systems. The point of our systems very specifically is, it's below ground, they're hidden. The part where we have these old legacy systems being ripped out, we can now put systems back in that are going to last for a long period of time. That's the advantage of precast. But I mean, Pete's far more of a specialist on designing them than myself. I know where products go. I know what fits. It's more down to the design elements. I know you've had conversations I was listening to there, wonderfully talking about innovative sort of surface level treatments that are hugely important.
But it's also, surface is a great way to describe it because it gives, so coming back to your first point about the water authorities getting the blame, it's because people pay their water bills and they pay their drainage bills. So people have got that natural connection to the water authority, and it's similar to the natural connection to water. And that's where surface SUDS is so easy to explain, because and that's where precast almost fails a little bit, because we're doing all the good work below ground that's stopping your area from flooding, but actually it's the above ground stuff and some of the great schemes that have happened from Cardiff City Centre to Mansfield. It's because people can see that natural connection to water, but then, as Steve said, the real volume has to happen somewhere. And it's funny with detention basins on housing schemes is a really difficult one, because you build a big house development site and you build a big detention basin right at the bottom of the site that's the cheapest part of the land that no one wants to build on anyway, and no one ever sees it. It's supposed to be amenity space, but it never fills up with water because the water never gets there, because it's designed for so high climate change, so you don't have that natural connection. But if you do that source control near the houses, smart, there's things like smart rainwater harvesting units that can release, at certain low points of drought. You have rain gardens and gardeners. The Chelsea Flower Show last year, they spent 15 minutes talking about this whole developed garden. It was all above ground, and you think people are scared of flooding, they're scared of seeing water, but actually you bring it into your garden and it's controlled and they can understand where it's going to go and that there is overflows and there is systems in place. It gets people excited. So I think, it's certainly bringing it to the surface, but then actually having the good infrastructure underground to deal with it in those worst case scenarios.
It's often really interesting that, on behalf of the members aspect of it, that's the very visible, interesting part that people see. A lot of what we do fundamentally is buried, hidden, lost. We've got an awful lot of challenges down there, and it's not just about our industry, it's about the entire below ground drainage industry. We've got tons of challenges down there, but a lot of it's hidden. A lot of it's items that aren't really at the tip of people's tongues. The flooding element, microplastics discharged, all contaminants and wetlands and everything like that is what people visibly see. Some of our challenges is some of the more interesting stuff below ground. We will move on to the carbon element of the impact of what we do. All this work below ground has a significant carbon cost, which is part of what we need to work on as well. It's not just our materials, it's the entire system below ground that needs to decarbonize as well. Another impact of what we do, and that's another significant challenge. It's the bit that's hidden, buried, those materials and products from all over industry below ground that needs to be challenged about decarbonising, smartening up what we do, better systems, longer systems, everything that you hear said, the same applies to what's below ground, but it's far more challenging because it's out the way, it's hidden, and it's not a public facing kind of problem, if that makes sense.
And one thing I was going to ask, staying on this, the precast idea here and motif. I think we were having a chat earlier as well, and thinking about also that current system issues and basically the lifespan and service life of the infrastructure underground as well. And I read a really interesting piece written by one of Steve's colleagues that talked about the 100 to 120 year lifespan of, say, a precast pipe as well. a lot of systems still fit for purpose in there? Is it a case that we need to rip out everything from the ground and start again as well, or are there ways in which we can kind of intervene and upgrade the systems that already exist?
I think one of the biggest challenges is actually understanding what is underground. There's assets, that we're just not aware of. Thames Water, I went on the site a couple of years ago and we had a CCTV survey done, and the Thames Water map showed a pipe system and got underground, got the camera in, and there was a humongous tank, concrete precast tank underground, and it was actually on a third-party land. So the landowner actually had a easement here that they didn't even know about it. It was written. Thames Water didn't even know about it. It was this massive asset was just silted up. As soon as we told the authority about it, they didn't care. Because it's not broken, they didn't need to worry about it at that time.
How many times has it been we've done I remember doing a development on the edge of the Thames in Stratford and digging something out to just put a manhole in, and you come across a giant red main feed water pipe, not in any map, not in any piece, and you think, wow, that's... Yeah. And but you talked a little bit about this, don't you? You've got some work on...
Yeah, we do quite a lot of work at the University of Birmingham on finding our buried assets, and that's not just our concrete pipes, it's any assets from cables, plastic pipes or so, and we probably know more about our stars than we know about what's below our feet, and that was, Leonardo da Vinci said that in 1500 and it's still true today. If we have statutory record data, you mentioned about Thames Water, but when you speak to the industry, so I do a lot of work with survey companies who try to find the buried assets, but also then with those who try to replace or repair them. And they said, well, you probably think that less than 50% of our statutory records are accurate. And then the question is, what do you actually mean by accurate? So again, I've asked, I said, what sort of uncertainty envelope would you put around your line that's on the map or on a GIS drawing? They said, well, plus minus 20 meters. I went, what? Because I was sort of expecting sort of plus minus a meter, plus minus 2 meters. That's the sort of what number I was expecting. But they said, no, we've seen it plus minus 20 meters out. It's actually in the other street. And a colleague of mine has done some work, which was then British Gas or so, trying to do some work on pipe splitting, pipe bursting, so some trenchless technologies. And they said the pipe was this side of the road. They dug a swimming pool size pit, could not find their pipe, and it turned up it was on the other side of the road. But the drawing said, the map said it was on this side of the road. So I think that happens so often. And then it's a question of how do we deal with the even if we find things are inaccurate, how do we pass on that information to the asset owners? How do we even identify the asset owner? I mean, we did the CCTV camera imaging, so that was probably relatively easy to know it was Thames Water. But sometimes if you're a contractor or so and you dig a trench or you dig an excavation, you don't necessarily know who it belongs to, even though you might find that something is not in the right place. I do know that the National Underground Asset Register is trying to address this in parts by at least pooling all the statutory record data onto one platform, because at the moment you have to go out to individual organisations to obtain the data. And there's been a trial done in the sort of within London, and they said that they have 93 asset owners that actually have assets in the ground within the City of London. So potentially you have to contact 93 asset owners to find what's in the ground in the first place. So it is a real problem, not really knowing where things are in the first place, and therefore if you then do your if you calculate your hydraulic flow rate, you do all your calculations, you clearly need to know what's there and also in what condition it is, because that impacts your flow characteristics.
We had a quick chat before as well, and around that replacement of failing systems, and so how easily can it be done? Having listened to what these guys have said as well, from your experience, what's the magic trick? What's the silver bullet?
Well, building on what Nicole's just said, the condition of the pipes underground you've got to assess. But if there is failing infrastructure underground, there's a lot of value and a lot of invested carbon in the fact that it's already buried. So the last resort should be to dig it up and replace it. There's now, Nicky also mentioned, trenchless technology. There are now many techniques for rebuilding the infrastructure from the inside, lining techniques, pipe replacement online, so without actually having to dig it up, and that I think is an important part of the network maintenance procedure. And that's a well-developed industry now. It's been going for 40, 50 years.
I think the interesting thing is retrofitting or thinking of working out capacities, and you talked about hydraulic. You often find that unfortunately the pipes underground just aren't big enough to deal with the revised pipe flows. But then it comes back to using better source control. So then you're actually limiting the flow back to what the pipes were originally designed for. And then actually you don't need to upsize your pipes because you've dealt with it at source and you're doing rainwater harvesting, you've got above ground surface water systems. Whereas often the solution is the pipe's not big enough, let's increase the pipe size.
In my experience, having come into the industry, a decade ago and more, looking at what some of the, and I will say for what some of the manufacturers do, where they've worked with some of the sort of innovative companies looking at hydraulic flow controls and things like that, where those guys excel. Some of the things that I see from industry side of things, where they've excelled is where they use a lot of the smart sort of technologies like vortex flow controls, interceptors, things like that. You talked about runoff and other pieces. Interceptors that go on the side of motorways, instead of just old-fashioned sort of silt chambers, which can work, can be very effective, introducing ready-built things that you can drop in, precast pieces you can drop in, where you've got these interceptors in them and can be done on maintenance periods, really has been quite staggering how much that's taken off. Flow control chambers, they were a simple thing when I started. We used to, 20-something years ago, 25 years ago maybe, you'd have been using orifice plates. Well, now we've got vortex flow control chambers, which reduce the size of tanks upstream. It's all designed to make that system a lot smarter, a lot more efficient, without moving parts, without really heavy sort of technology needed. Smart pieces of work, and I've been very, very lucky. We worked on some huge projects. Again, some of the most interesting stuff has been buried, will be locked away forever, which is quite unfortunate. But these chambers have been, these pipe systems have been incredible, very smart. Way over what the layperson would think has been put in, and it helps systems reduce size, reduce cost, but just in general, just much smarter at controlling that whole thing where we've urbanised an area and then need to deal with the system before we discharge it.
If I can add on the source control, obviously speaking predominantly about the amount of water going through, but it's actually the quality of the water that on my side of things that I'm looking at. And it's the same thing. If you can control at source and you can remove a contaminant at source, it is so much easier to do than it is at end of pipe. So if you're at a sewage works and you have a contaminant that you have to reduce to 1 part per billion, for example, and it comes in at 10 parts per billion, it's really hard because you're trying to remove a very small amount out. Whereas if you're at the source of where the contamination is occurring and it's at very high concentrations, you can remove it much more easily and much more simply, much more cost effectively, and then you don't have to remove it at end of pipe. Because obviously it's not then getting mixed in with all of the other water and being diluted. And while people think it would be easier to remove when it's dilute, it's actually not, it's the opposite. You don't want to be doing ion exchange and extremely expensive cleaning techniques at the end of pipe. If you can catch it at source and do some quite basic cleaning at source, you can really improve water quality all the way through the system. So I agree, source control is really important.
Might just mention that one other source that hasn't been touched on yet is just leakage into the system.
Oh, yeah.
Because of course, with our combined sewers in this country, the overflows into watercourses are not just due to storm excesses, but also due to leakage into the system. So making the system watertight is actually very important as well.
Yes.
Steve just talked about treatment devices and Faye's talked about sustainable drainage and systems to control pollution and water quantity. They all need maintaining.
Yeah.
So we need to find them, map them, know where they are and have a maintenance schedule pinned to the wall somewhere, because lack of maintenance of assets is horrific, and we'll sit around this table again in 10 years' time wondering why maintenance hasn't taken place. And we've got to fix that.
But maintenance also helps with knowledge sharing. So that asset doesn't get forgotten
So,
because it's getting maintained.
Every year
Yeah.
somebody's, but the problem at the moment though is if George, who does the maintenance, retires, that knowledge is lost because we have no central repository for that information. So George retires and the device is never emptied again.
But, so you and I used to see this on a simpler thing as like silt traps on highways. Lack of maintenance on those can be catastrophic downstream. Like, you know, the minute a storm hits and starts to stir one of those up, then you have discharge downstream. You know, you can put the best systems in, and we used to make hundreds of these things, put them all down the side of the motorway, and all of a sudden, 10 years later, not maintained, full of silt, and that then just leads to discharge and problems further down.
But also, when you're talking about the maintenance as well, it also they need to have a skilled cohort of people who can actually do the maintenance as well. And as you're saying, the knowledge is lost. There's obviously a deficit within that sector as well. So that maybe, you know, for the next roundtable, we can be talking about the skills shortages we face to deliver all these great things.